Hello, everyone. Welcome back to another Ubuntu Online Summit. This is a two-day event that starts at 1400 UTC every day. So that's 9 a.m. Eastern Time, and it runs until 20 UTC. Like I said, it's 2 days, today and tomorrow.
9 a.m. Eastern Time, and it runs until.
All right, sorry about that. Left the tab open and it started auto-playing. Anyway, this is a two-day event. It's multiple hours each day. We do have a lunch break in the middle. We have compressed the schedule a little bit this time. We're going to try and make it easier for people to attend more of the sessions that they wanted. So we've tried to keep it to only 2 concurrent tracks per hour. So that should make it a little bit easier for you. If you're watching this, hopefully you're watching this on summit.ubuntu.com. If not, I will show you how to use that. So if you go to summit.ubuntu.com, you'll see this page right here. If you have not already registered to attend, please do that. That lets us see how many people are watching these events, so that we can make sure that we're using our time effectively and getting out to the most people we can. So please register yourself as attending if you're watching any of these sessions. We'll also send out a survey at the end to get feedback from you. Your feedback helps us improve these, so please go. All you have to do is log in and register, and we'll get your email address from Ubuntu Single Sign-On and send it to that one. Once you're signed in, you go over here to UOS November 2016. That is today and tomorrow's event. And here at the bottom, you'll see our schedule. It's broken out by day, by track, and by room. The easiest one to do is just go check on the day. So we'll go to 2 days. And here you see all of today's events that are on the schedule. Now, once you're registered to attend, you can create your own personalized schedule by clicking on the events that you want to attend. So say you want to attend the Creating Your First Snap session here. You just click on the little star icon next to it. It's got you set as attending by default, so you click Save. And then when you go back to your schedule, you'll see it's got a little yellow star there, and you'll also be able to get your own personal schedule if you come up here to your My Schedule link at the top. That will show you all of the stuff that you've marked yourself as wanting to go to. So, like I said, 2 days, about 2 sessions per hour. They will all be in roughly this format. There'll be a video at the top, and below that there'll be an embedded IRC. The IRC channels correspond to the room that your session is in. So if you have a regular IRC client that you would like to use instead of the embedded web IRC, there'll be a link to that. They're all hash Ubuntu -UOS and then the room name. So plenary for this one, cloud, core, community, whatever the session that you're going to be in. And those are all on Freenode IRC. For most of the sessions, they would like to have some audience participation. So while you're listening along, if you have some questions you want to ask the speaker, just start them with the word question in all capital letters. And somebody will be watching an IRC and try and answer those for you. Again, that's question in all capital letters. All right, and that is it for the intro. It's pretty easy. If you've been to an Ubuntu Online Summit or watched an Ubuntu On Air, then you're already familiar with the way this works. So I'm going to hand it over now to Gustavo, who's going to give our opening keynote for today.
Hello, everyone. Let me try to set that up. Hopefully my screen sharing will not disappoint me this time. Okay. Can you see that properly, Michael?
Yep, looks good.
Okay, sounds great. So today I'm going to talk briefly about what has been going on in the land of Snappy, Ubuntu Core, Snapd, Snaps, and so on. It's going to be a short overview of the past several months of work. A lot of what I'm going to talk about actually happened since 1604. So it's probably news for anyone that hasn't been following closely. And then I'll briefly talk about what's going to come up next, at least what's in our minds at the moment. So Snappy has been an epic project for us. We have been solving some, both, you know, in many senses, we have been solving some really interesting problems that are dear to our hearts. The problem of package management is, you know, we know it's close to the foundation of every single Linux distribution. So it's a problem that we want to address in a good way. And Snaps offers an agile system and a safe system as well, as you probably have heard about by now. And also in the sense of it's epic in the sense of the speed of development as well that we have been going through. The last year, it's in some senses we've just had a sprint a couple of weeks ago, and we were talking about how it feels like it's actually multiple years of development just that last year alone, given so much we've done in that time frame. And I cannot go into details without talking about the team. It's been indeed a joy to be part of that team. You know, it's a very small team compared to many software projects, and you know, we've been working intense hours and in a really pleasant way as well. So it's what I'm going to describe today is only happening because of that team. In fact, not only because of the team itself, but also because of the help that we've been having as a team inside Canonical. The collaboration that has been happening both in terms of across teams and also from the community popping in and out, it's been amazing. I've been part of many projects before, and it's the first project I see so many people from different areas popping in and helping and enhancing the project in specific ways, and then sometimes, you know, sticking around for longer and improving smaller aspects of the project, or sometimes big aspects of the project, and sometimes people go back to their teams and share the knowledge and continue working from there. So it's been really a joy to be part of that effort. So let's talk about then what happened just recently in terms of the development of snapd, snaps, and so on. Assertions is something that you may have heard about. It sounds fancier than it actually is, and it sounds fancier because it's actually an interesting foundation that allows us to do many things. So assertions by themselves are not super interesting. What is interesting is what we can do with assertions. We've been talking about them for quite a while, and just in the last few months, we finally started to see the benefits of that framework that we developed such a long time putting in place. Assertions, in the most pure way, assertion is a signed document. It's just a signed knowledge. So when we have a signed assertion, the snapd system, the snap system, will trust that assertion depending on whose authority it was signed after. So depending on those factors and depending on the information that comes inside the assertion, snapd will behave in different ways. So we have many different kinds of assertions, many different types of assertions, conveying different kinds of information to the system, right? So that's why I say that an assertion by itself is not so interesting. What is interesting is what the system does with the information that it gets and that trust that comes with that assertion. So, for example, snap declaration is one assertion that is now being used. Snap declaration is the piece of information that gives snapd all the general details about a specific snap. And when I say general details, it's sort of that doesn't even make sense. So it's the details for the snap that are common across revisions, right? I guess that's more correct. So, for example, the assertion tells details such as the name of the snap itself that the system should respect as, and this may come as a surprise to some people because usually we are used to in Linux having the name coming inside the deb or the RPM itself, right? But sometimes that creates problems because given legal actions from third parties, we're forced to change the name. So that's a mechanism that enables us to do that across the system without too much pain. And also more other details such as what interfaces what sensitive interfaces that Snap can carry and so on. So all of that comes then in a signed document that snapd looks at and says, oh, okay, I know I can trust that snap and I can trust that information because somebody that I trust told me that this is the case. Validation is another assertion, for example, that enables somebody to say, look, I've tested that snap and with that other snap, and they both seem to work together well. So you can take the necessary actions for after that fact. And then snapd will behave in different ways depending on that sort of information. System user is an assertion we introduced just recently to enable the system to create when you're just. This is most interesting in the Ubuntu core case, which is an operating system that is purely made of snaps, and the system user assertion is the one that says, look, this is my key, this is my SSH keys, this is my typical username, and I'd like to create a user on that system, right? So this comes in as an assertion as well, signed by a party that the system will trust. So this is, and of course there's several small details about the security implications that this happens. It all happens in the same way, but this is a good mechanism for allowing, for example, us to get out of the issue of having default system users, right? We've all seen recently in the past few weeks, which is quite timely, the effects of having devices in the cameras and so on with standard passwords or just with weak security, right? So this is a mechanism that enables us to not have a default username and password for those devices, and it works through an assertion. I won't go into the details of that today, but you can put such an assertion into a file, and the system will recognize, for example, a USB stick that comes with an assertion signed by a trusted party. Console conf was also something that happened just in the last couple of months. Of course, not the development, but let's say the release and the visibility of the project. Console conf is the system that when Ubuntu core is starting, it shows off in the screen and allows you to type in your details to create an account in a much simplified fashion. The system of hooks is one that has been coming for quite a while. Since 1604, we wanted to have such a concept introduced into the system for many different reasons. But instead of just having a system that executes a binary or an executable shell script or Python script inside the snap, we wanted to have a more reliable system that enabled us to expand the number of hooks and expand the sort of capabilities that we could have in the system in a very nice way. So we spent several months developing the underlying infrastructure for having those proper hooks, and then just recently in the past few releases, and actually the configure hooks itself is still the dependencies for the configure hook are still being released into 1604, but just now we've started to see the benefits of having that infrastructure in place. So as I just said, one of the examples that we can see is the configure hook. The configure hook is what enables a user to type into the command line, for example, or via the API, set that configuration option into that snap, and that will translate into a hook being called inside the snap. So simply being, run that binary and let it do whatever it wants. There are many details about how to make that process work correctly. Just in terms of configure, for example, we have here an example. It says at the top, you can see a command line being executed to set a configuration option foo in my snap. When that happens, snapd is called, and an API is the API of snapd itself is called, and snapd will then generate and record the fact that there's somebody attempting to do that operation, of course validating authorizations and so on, and then it will execute the actual hook into a confined environment using details that were specified for that particular snap. And the hook itself then has the chance to talk back to snapd through a convenient tool called snap control that enables it to ask for the details it wants. It can ask for, in that simple case, it can ask for the configuration foo so that it can get the value. But snap control will have many other settings and many other possibilities that will allow the hooks to become richer and to have interesting bidirectional communication with the daemon. And it's interesting as well to notice that snap control can be, even when talking about configuration, that command can run not only inside the configure hook, but also inside any other hook, and soon even outside the hook system, just inside any other part of the snap that is executing. It can talk back to the daemon and say, look, I want to do those actions, or I want to get that configuration option, or I want to change that configuration option. So it's really a bidirectional mechanism that enables the snap to act. Snap control itself, of course, runs also in a confined environment. So everything you see in yellow here, for example, would be working in a confined environment. And as I just said as well, the fact that this looks like a simplistic process where it's just snapd running a hook, which is an executable, doesn't give the full picture of what's going on here. There's actually the fact that there's a hook running was recorded so that even if some event happens, if a reboot happens, or if something crashes for whatever reason, this operation will continue soon afterwards, as soon as snapd can recover itself and continue the operations that were in progress by then. We have already other hooks as well. Another example is prepare device, which is specific to Ubuntu core, and it enables it's a hook that runs very early on in the life cycle of the device to do custom operations for that device. Mount namespaces is another feature that's landed recently. We also spent quite some time discussing and implementing that feature. It's interesting because it's despite being quite tricky to get correctly, it's the sort of feature that ideally is invisible, right? Because if it's working properly, you just won't notice, because what you wanted is what's going on. But for example, there's quite some effort to make sure that all the snaps, all the applications in a given snap are seeing the same namespace, the same mount namespace, so that the file systems actually share between them. But when you have a different snap, that different snap, the application inside that other snap will see again their own namespaces and so on. And excuse me. And this is of course very interesting in the case of snapd, because the applications run in fact as let's say the ancestry of the applications is correct in Linux terms, right? When you run something in the shell, the applications you're running are actually a child of the shell. And when you run them under systemd, they're child of systemd. So there's several details, again, which when they work properly, you just don't notice because that's exactly what you expect. Snap run as well is another very interesting feature that we've working for quite some time, and it was slowly rolled out, and just in the last couple of months, it finally the full pictures finally became real. This is the main pipeline of how an application is executed inside a given snap. So, for example, by now, if you look inside Snap bin, you'll see that everything inside there is actually just a symlink into the Snap binary under user bin. So it's a much cleaner, much simpler mechanism. As a side effect of that, we also have environment variables being much more flexibly defined. They can be defined by now inside the snap.yaml and so on. I apologize for the pause. I don't know if you can see me, but when I'm not speaking, I'm drinking some water. Snap run -- shell is just one of the benefits of that pipeline I just described as well. By now, if you type snap run -- shell, you will get a shell that is really useful when you want to debug what's going on in a given application, because the shell is confined and is executed in the same mount namespace and so on as the actual application inside a snap would run. So it's super convenient to be able to understand what exactly is that application inside that particular snap saying about the system. Revision garbage collection, as we call it internally, is simply the fact that we right now we have 3 revisions that are installed, and when the 4th revision is installed into the system for any particular snap, the 4th oldest one is then removed. So it's basically a window of 3 revisions going forward. You will always have, when you install a snap, you will always have the last snap that you, sorry, let me be more clear. When you update a snap, you will always have the last revision of that snap installed and the 3 last revisions that you had installed, right? And the maintenance of the old ones, they get removed automatically by the system. This is super interesting because it enables you to roll back for the past few revisions that you had working very easily, right? Instead of having to dig what you had before and so on, you can simply go back and say snap reverts, and it will revert automatically into the last revision that you had working. And depending on how you set up the data, or how the snap author has set up the data storage inside that snap, it will also revert into the old data. So it's a really nice mechanism, not just for desktops or phones, that is, the context, or small devices, which is the context we see snaps originally associated with, given its Ubuntu phone origins with Click, but with Click packages. But it's super useful as well in the server environment. I've recently updated several of my personal servers to use snaps, and honestly I'm having a blast doing that. I should probably have another talk just to describe that. Snap enable and disable, super convenient functions that are obvious in retrospect. They simply disable the snap without removing it. So you have it inside the system, but the confinement is all, the confinement allowances that were provided to that particular snap are all lifted off. So the snap cannot actually do something inside the system, but it's there for you to introspect, and the data is still there as well. So you don't have to remove the data or the snap just to have it disabled for the time being. Revert, I just talked about, is the thing that enables you to go back to a prior revision, or even to a forward revision as well, as strange as it may sound. When you revert, let's say you revert twice to the 3rd old revision you had installed, you may want to revert forward, which means you get the data that was on that particular revision, right? That's the main difference between reverting and refreshing. When you revert, you basically tell Snapd, hey, I'd like to have that particular revision with the data that was there before, and not my new data, so that I can, so that I can try to recover my system, or so that I can get back to a working revision. Snap connect and disconnect are still the same, so they were there already by 1604. But as I said below, it's finally sane. They were quite picky about how they worked, in the sense that you had to specify exactly the details of how you wanted that interface to be connected between the two snaps, and by now it's much more saner. Basically, you have many use when you don't want to specify the full thing. It will basically tend to work well by default. I encourage you to have a look at the help for those commands if you're curious. By now we have more than 50 interfaces in the system. Interfaces, if you're not familiar with snaps yet, an interface is basically the proper mechanism for unconfining a snap in a controlled way. In other words, confinement is of course very important. We all want things to be confined, so that they're not abusing and they're not getting any more access to the system than they need to. On the other hand, they need to have some sort of access, right? So the interface system in Snaps and Snapd are precisely the mechanism that enables you to tell when you're using a snap what you want that snap to be allowed to do, and when you're producing the snap is the mechanism that enables you to say what you'd like what you need that snap to be able to do for it to be functional. Not all interfaces have to be connected all the time. The user has a choice of what to connect and when, and the system also has opinions about what is safe to connect and what is problematic to allow without user consent. So there are some subtleties into that process, but that's basically it. It's the mechanism that enables you to define what sort of unconfinement you want for that particular snap. And by now we have more than 50 of them, and that number is growing very quickly, of course, because as more snaps have to do more actions and more interactions in the system, and as the number of snaps grow, those interactions also become richer. So it's natural that this number will expand quickly. Ubuntu Core was just released a couple of weeks ago. The final release, that is, of the let's say the modern Ubuntu Core that is based on Snapd and the current incarnation of snaps. And again, as I said earlier in the talk, the Ubuntu Core is very easy to understand. It's basically a full operating system that is comprised solely of snaps, right? So the only thing you have on the system are snaps. And when I say only snaps, that's literally it. Even the kernel, for example, and the operating system itself is a snap. So everything can be updated very easily as a snap inside Ubuntu Core, and inside other operating systems that choose to use Snapd as their main operation mechanism. As a number of things happened as a side effect of this work, the Gadget and kernel YAML specifications were refined and stabilized, and they're now very pleasant to read and to produce. Gadget.yaml is the thing that enables you to describe how a gadget, in other words, should look like. And kernel.yaml, as the name implies, is the snap that holds the kernel snap is the snap that holds the kernel, and kernel.yaml holds the details specific to that. And those are used by Ubuntu Image, which is a new tool that has been developed over the past several months, which take a Gadget.yaml specification, and they can produce a full image, a full working image, that it can boot in systems in many different ways. So this is as most things in Snap, this is a super interesting cross-team effort that we've been working on, and it's as what I'm really excited about in that sense is that it consumes a very nice specification of how the image is supposed to look like in the end. So we're soon gonna see Ubuntu Classic images as well, using the same sort of specification. So it's a very nice language, let's say, to collaborate across teams. The process of booting and seeding was largely improved inside Ubuntu Core. That improvement was not in terms of adding complexity. I think it's fair to say that in most cases we've actually significantly reduced the complexity of those processes, and that's very good, obviously, because it means increased reliability as well. We've renamed the Ubuntu Core as it's because of our cross distribution efforts in Snapd. And actually, that's an interesting parenthesis to open here. A lot of the things I'm describing here, and I guess pretty much all of it, is not specific to Ubuntu or to Ubuntu Core. It's all native into Snapd and Snaps and the Snap tooling in general. So if you are in any other distribution, Debian, Fedora, CentOS, and so on, you can benefit from those improvements as well locally without having to use Ubuntu. And as I was saying, as part of that process, we've also debranded the Ubuntu Core Snap, which is not Ubuntu Core anymore. Now the Snap is called simply Core. It's a trivial change from the outside, but it's interesting semantically, and it was quite tricky, of course, because there were several places in the code that trusted that to be the case. 14.04 support is coming, so Ubuntu, we really hope to get that nailed down. So we wanted to see Ubuntu 14.04 running with snaps soon. LXD and Docker, they both work as a snap by now. So this is also a very nice outcome of the past few months of collaboration. Classic, the classic snap, which is valid mainly for Ubuntu Core. The classic snap is actually a curious case, because if you are running Ubuntu 16.04, if you're using the classic Ubuntu 16.04, you can install Snapd and you can use snaps inside your classic system, right? So you can have all the benefits of having snaps at hand very easily by installing a Snapd dab. If you're using Ubuntu Core, all you have are snaps, right? But you can use the classic Ubuntu system by saying snap install classic. So all of your typical Ubuntu tooling, including apps and dabs and so on, they're all available inside that classic snap. So this is a very, very convenient mechanism that enables you to not be constrained, let's say, by the several, fair to say, good aspects of Ubuntu Core. Because it's limited, it's small, it's restrained, it's constrained in terms of many things being read-only and so on. But of course, in some cases, you just want to hack in your usual environment to get something working or to discover how something works. So if you want to do that, you can just say snap install classic, and it will happen. Payments, snaps. This is something that also has been landing in the last few months. Payments has I think it's fair to say it works right now. I don't know how many snaps we have, or if you have any snaps that are paid right now, because that's not been our focus. But I believe it's fair to say that payments work already. So if you have a paid snap, you can publish it via the store, and inside an Ubuntu system, you can install it. Inside in the system, you can probably install them as well. I haven't tested that myself, but that's the goal. Spread is our distributed testing system. So we've been greatly expanding the number of tests, and I mention this here mainly because it gives you a sense of how much we care about stability. We have Spread working across many different instances. So every single pull request, every single branch that lands goes through a battery of tests, of hundreds of tests, and that runs across several different machines and several different environments. And so we've been over, since we've released 1604, this is one of the interesting things that we've done as well. And by now, all of our systems are being tested that way. Here you have a very, very quick, very short excerpt from the output of Spread running inside Travis. You can see it's in parallel running across different systems, different machines, different versions of the operating system, and so on. So we have just about 5 more minutes, I think. So I'm going to quickly dive into what the upcoming future looks like. Not yet promises, but what very likely will be showing up in your nearest Snapd and Snap environment. More documentation. This is a spot I'm very interested in getting solved. We have quite a bit of documentation, but the system is so rich that it's very hard to keep the documentation up to date with everything it can do. And given the tight timelines we try to work over as well, sometimes the documentation gets left behind. So we're going to be trying a few different experiments to try to get that sorted. And perhaps it won't work the first time, but I hope that we can nail it down soon. Snappy info, it's a pretty obvious one. We want a command that shows the basic details for a snap. This is surprisingly missing. We have several let's say several different ways to inspect a snap, but we don't have one way to say, give me all the information about that snap. So you can expect that commands to be landing quite soon. More top-level commands, which means right now, if you want to package your software as Snap, you get one top-level command, which means, for example, if you pack my snap as a snap name, you can have a command inside it, which is my snap as well. Every other application that you register inside a snap is named my snap.application name. And we want to enable snaps to have any sort of commands, right? Any sort of top-level commands. So this is one that is also dear to our hearts, because we know that it's inconvenient to use tooling that doesn't follow the usual names you want to call your own tools as. So this is one we're going to solve soon. Deltas is pretty much implemented and coming. You will be able to upload deltas, and you'll be able to download deltas as well. There's already several branches working towards that, and I expect, with excitement, I expect it to see it working quite soon. Interface hooks. I've talked a little bit about hooks early on, and interface hooks is basically exploring that same mechanism to allow you to register interest from your snaps into what should happen when an interface is connected, and what should happen when an interface is disconnected. And there's a specific sequencing that we're interested in exposing to snaps. So you can expect that to happen soon as well. Hot plug. So we will support hot plug of hardware inside to enable snaps to register their interest on things that come and go. So this is one that we know we want to get it solved in a really nice way. More spread. We have quite a few systems running already on every single pull request, but we think that's not enough. We'd like to have more distributions. We want to have Debian, Fedora, CentOS, and other distributions running on every single pull request that we make to make sure that there are no regressions on any single change that we land. Custom Rootfs is a really nice one. Several people asked for that before, even more in the cross-distribution scene. It's basically going to be a way, and we're calling it actually base snaps. It's going to be a way for you to be able to replace the basic files that today comprise the root file system of your of what the snap observes in its environment by whatever base you want. So if you want to have different distribution for with custom files, custom libraries, and so on, this is going to be a way to do that. It's interesting to note that this is not about sharing libraries, right? That's not about, if you have, for example, Qt or KDE libraries, and you want to share that across separate snaps. There's already a way to do that via an interface. You can reach out to us, and we're going to explain exactly how it works. And it's a much nicer way to do that than replacing the whole base snap, right? But we will support as well in the future replacing the full rootfs, which is base snaps. Custom channels. This is a feature that we'll support soon as well. We have a super nice specification from the last sprint, and I won't talk too much about it right now, but you will see something surfacing in that area soon, and you know, expect good things in that area. Cache and restart downloads. This is, you know, one from the obvious grounds area. Right now, the downloads are pretty simplistic. It works quite well, quite reliably, but somewhat simple still. We want to have a few more interesting twists on that, and so much more. We have, you know, I don't have time today to go over every single thing we have in our plan, but rest assured we have many good things coming that you'll see landing every day. Most of the features I described, those are features that you'll see landing. We have releases for Snappy pretty much every other week, so you can expect things to land in 16.04 in your preferred Linux distribution if it's not Ubuntu, and in Ubuntu Core as well. If you're just using it, it will be automatically updated, and you can get those new features quite soon. So that's it for today. Michael, I don't know how you want to move from here on. Do we have time for questions? Do we move on to sessions because we're right on time?
Yeah, I think we're just about out of time. There were quite a few questions that we wouldn't be able to get through all of them.
Okay.
But for those who are interested in snaps, if Gustavo's got you wanting to start working on a snap of your own or learning more about them, in the next hour, we have a session on creating your first snap that's going to take you through the most basic pieces that you need to do in order to actually start making a snap package. It's not going to go through everything that Gustavo's gone through because most snaps aren't going to need all of that. They're just going to need a small subset of it. So that'll get you started. And then the hour following that, there's a snap roadmap Q&A where you'll have a lot more time to ask more detailed questions and get a proper answer to those. So if you're interested in snaps, please go sign up for those sessions and don't miss them. Join the IRC, ask your questions with the word question in all caps there. I know some of you started doing that in this one. We don't generally take questions on the keynotes though. So take them to those. If you're running one of those sessions or just participating in them, please keep an eye on the IRC channel for that room. And if any questions come up, get the speaker to answer them.
Sounds good.
All right. Well, thank you, Gustavo. Thank you, everybody, for watching. And I hope you enjoy the rest of the Ubuntu Online Summit. We will see you in the sessions.
Indeed. Thank you very much. Thanks, Michael. And thanks, everybody.
Bye.
Enjoy. Cheers.